In this video, I'll be discussing a divisibility problem. 200 students numbered from 1 to 200 are lining up and facing south. Commands are then given by the teacher. After the first command, all students turn to the right, so everyone is facing west. After the second command, all students are multiples of 2 turn to the right. After the third command, all students that are multiples of 3 turn to the right. And then this pattern continues all the way to the student number 200 turns to the right after the 200th command. At this point, how many students are facing east? So, for this problem, you have 200 students, and they're numbered from 1 to 200. And well, we have our compass to better illustrate the problem. In north, south, east, and west. So all students begin at south, and then after the first call, everyone goes to west. And then after the second call, those who are multiples of 2 go to north. And after the third call, those who are multiples of 3 go to east. And well, remember that after the third call, well, those who are still at west but are multiples of 3 will go to north. And this cycle just continues. The question asks us, after the 200th turn, how many students will be at east? Well, east, a cycle around it will be south to west, west to north, north to east, east to south. That will be 4 turns. East will be 3 turns. South to west, west to north, north to east. So, turn number will be 3. Or you can go another cycle after this 3. So it'll be 3 plus 4 equals to 7. Or 7 plus 4 equals to 11. And then 11 plus 4 equals 15. Go dot dot dot. But note that after cycles like 15, the numbers will get very huge. So it's not going to continue for that long. Okay, now, these turn numbers are all added 4. So 3 plus 4 equals to 7, 7 plus 4 equals to 11, and 11 plus 4 equals to 15. Let's first do the 3. Well, note that each turn is decided, the number of turns for a student is decided by the number of factors it has. So a student with 3 factors will get to turn thrice. And what kind of number has 3 factors? Well, it's going to be the perfect square of prime numbers. Because you see, okay, let's go to the first one. 3 factors. Or 3 turns. You see, the perfect square of prime integers will be the only kind of number that has 3 factors. For example, 4 equals to 2 squared. It has factors 1, 2, 4. 9 equals to 3 squared. It has factors 1, 3, 9. And then the next prime number will be 5 squared. So we go 25. It has factors 1, 5, 25. Note that it can be the perfect square of a composite number, because composite numbers have more factors besides 1 in itself. So we have more than 3 factors. And then it will be 7 squared equals to 49. 1, 7, 49. 11 squared equals to 121. 1, 11, 121. And last one will be 13 squared, 169. 1, 13, 69. Wait, 169. And then the next prime number will be 17. But 17 squared equals to 289. 289 is larger than 200, so it won't work. So we have 6 numbers for 3 turns. Go to the next case, 7 turns. Well, 7 turns equals to 7 times 1. 7 equals to 7 times 1, or 1 times 7. But then note that you have to find the number of factors for this number. And just saying, how do you find the number of factors? You have to use this formula. So say we have the number We have an example here. So you have the number 6. 6 equals to 2 times 3. To the power first power times 3 to the first power. The number of factors will equal to 1 plus 1 times 1 plus 1. So we got this because we added 1 to each of the exponents of the prime factor. So this means that 6 will have 4 factors. This is true because 6 has factors 1, 2, 3, and 6. So now, note that if you want 7, 1 times 7, it will be 0 plus 1 times 6 plus 1. So this will mean that this can only be a number with a prime factor to the power of 6. It can be like two different prime factors multiplied together. Because 0 means that the exponent is 0, and anything to the power of 0 will be 1. So it's not counted. So let's continue with the smallest one. 2 to the power of 6 equals to 64. And it has 7 factors. 6 plus 1 equals to 7. 3 to the power of 6 equals to, it'll be 81 times 9, 729. And now, larger than 200 will not work. So there's only one case for 7 terms. And for 11 terms, well, (11) equals to 1 times 11. So this means that it'll be a prime factor to the power of 11. You see, now this one's going to be 2 to the power of 11. And then it'll be 2 to the power of 10, because 10 plus 1 equals to 11. This will equal to, it'll be pretty big though. It'll be 1024. And well, obviously this is larger than 200, not work. This means that there's no possible solution for 11 terms. So no solution. Okay, I'm gonna get it here. For the fourth case, like 15 terms. 15 equals to 1 times 15. Well, we're not gonna use this one, obviously, because starting from 11, the numbers get too big, you know. So 1 times 15 will be something to the 14th power. That will be obviously larger than 200. So this means that this will equal to 3 times 5 also. It will be 2 plus 1 times 4 plus 1. This will mean that this will be a combination of 2 prime factors. These 2 prime factors, one of them will be to the power of 2. The other one will be to the power of 4. So let's start with the smallest one. Will be 2 to the power of 4 times 3 squared. This will equal to 16 times 9, equal to 144. This works. Let's go to the next one. D to the fourth power times 2 to the fourth, 2 to the second power. Will be 81 times 4, 324. Larger than 200, which will not work. So once again, 144 is the only one that works. And then now, starting from the fifth one will be 15 plus 4 equals 19. 19 terms. Well, 19 terms, well, starting from that, the numbers get too big. Because, you know, already from 15, we are shown that any number, any composite number past this will not work. Because we already shown that at 3 to the fourth power times 2 to the second power, it's already larger than 200. So any number past 15 will not work. Prime or composite. So then, you'll get that it will be 6 plus 1 plus 1 equal to 8 students facing east. And that is how you solve this problem. Well, to solve this problem, you have to notice that the term numbers will be 3, 7, 11, 15. Then we have to use the number of factors formula to find out what kind of number will have 3 terms, 3 factors, 7 factors, 11 factors, 15 factors. And then after that, we have to notice that after 15, numbers get too big, so we can stop counting after that. Also, notice that The only numbers that have 3 factors are perfect squares of prime numbers. So then we get the final answer of 8 students facing east. Thank you for watching.